The population of a town 2 years ago was 62,500. Due to migration to big cities, it decreases every year at the rate of 4%. What is the present population of the town? Well, every data here is given. You just have to put it into formulas and get the answer. So the present population of the town is equals to the initial population, which is 62,500, times 1 minus, because it is decreasing, minus r upon 100. So r is 4%, the rate is 4%, by 100 raised to 2, because it was 2 years ago. So this is equal to 62,500 times 100 minus 4 is 96 upon 100 square. So this is equal to 62,500 times 96 square is 9216 upon 100 square is 10,000. So these zeros get cancelled out. So this is equal to 625 times 9216 is equal to 576,0000 upon 100. These two zeros get cancelled out. So what remains is 57600. 57,600. So option B is the correct answer. The value of a machine depreciates at a rate of 10% every year. It was purchased 3 years ago. If its present value is rupees 8,748, its purchase price was. So let the purchase price, which is the initial price, be X rupees. We know what is N. N is 3 years. And the current value is 8,748. So I can write 8,748 is equals to the initial value, which is X, times 1 minus, because the value of this machine is depreciating, the rate is 10%, so 1 minus 10 upon 100 raised to N. N is 3 years, raised to 3. So this is equal to 8748 is equals to X times 100 minus 10 is 90 upon 100 cube. We can cancel this 0 here. So we have X is equals to 8748 times 10 cube upon 9 cube. So we can write 9 cube as 9 times 9 times 9 and 10 cube as 10 times 10 times 10. I can divide 8748 by 9, so cancelling out this 9 gives me 972, which again divided by 9 gives me 108, and 108 again divided by 9 gives me 12. So this is equal to 12 times 10 times 10 times 10. So that is 12,000. So the answer is option C. The depreciation applicable to an equipment is 20%. The value of the equipment 3 years from now will be less by. So let us consider that the current value of this equipment be 100 rupees. Okay, let it be 100. Now this is the initial value. After 3 years, the value will be equal to the initial value, which is 100, times 1 minus, because it is depreciation, the rate is 20%, so 20 upon 100 raised to N, and N is 3. So this is equal to 100 times 100 minus 20 is 80 upon 100 cube, and that is equal to 100 times 8 cube is 512 divided by 1000. So these two zeros get cancelled out. So I have 51.2 as the value after 3 years. So it is asking the value of the equipment 3 years from now will be less by. So after 3 years the value will be less. How much the value will be less from the current value? So current value is 100 minus the value after 3 years. So 100 minus 51.2 will give you 48.8%. So it will be less by 48.8%. And why percent? Because we took the current value, the base, as 100. So I can comfortably say this as a percentage. The population of a town increases by 5% annually. If the population in 2001 was 1,38,915, what it was in 1998? Well, let us first calculate the number of terms, the n. So the total number of years from 1998 to 2001 are 3. Therefore, I can write n is equals to 3. We have this 5% as the rate, and this is the final value of the population, because it is given that the population in 2001 was 1,38,915, what it was in 1998. So we have to find out the initial value of this population, right? So final value is equals to 1,38,915 is equals to the initial value, let's say it is x, times 1 plus the rate is 5%, so 5 upon 100 raised to n, and n is 3. So this can be evaluated to 1,38,915 is equals to x times 105 upon 100 to the power 3. Now I can divide this by 5, numerator and denominator by 5. 5 times 20 is 100, 5 times 21 is 105. Therefore I can say x is equals to 20 cube. So 20 times 20 times 20 times 1,38,915 divided by 21 cube. So 21 times 21 times 21. So this is equal to, if I divide 1,38,915 by 21, I get 6,615. And if I divide again this 6,615 by 21, I get 315, and which again divided by 21, I get 15. So I have 20 times 20 times 20 times 15. So therefore the value of x is equal to 1,20,000. So option D is the correct answer.